Hello everyone, welcome to organolysis. So this is our conceptual problem solving part. Now here I am choosing this selective rearrangement reaction is that PUMMERER rearrangement. Okay, so this PUMMERER rearrangement is very much important for your CSIR-NET and GATE, and question also asks from this topic. Okay, now see in case of PUMMERER rearrangement, our prime motive and the prime motive of this rearrangement reaction is that you have to substitute this alpha position followed by the removal of this group. Now if you see the product from this substrate to this one, now you see that you have given this R1 and R2, and here you have placed this ketone. Now this is this position, like this one, that is this bond is collectively cleaved, and you get the removal of this part and you get the alpha substituted product. Okay, so for this you have to know that this important reaction, that is PUMMERER rearrangement, and how the reaction proceed and how the mechanism of this I will show you all over those things. Okay, now let's start. And now at first you have to see the steps. Now what types of steps, and what is the reagent, what is the solvent, and what is the nucleophile, all those things you have to know for this reagent. Okay, now see, at first you have given the substrate like this, that is S double bond X. I am written over this X. X is just nothing but X is maybe your oxygen, maybe your NR bond. Okay, now if the oxygen is placed over on this X in presence in case of X or NR, now if the oxygen is placed over this X, then the name of those compound is called sulfoxide. Okay, sulfoxide. Now if the NR is placed on the position of X, then it is called sulfinamide. Okay, sulfinamine. Okay, sorry, not sulfinamide, sulfinamine. Okay, sulfinamine. Now what is the activating agent? Why this activating agent is needed for this reaction? Just because of this activating of this SO, if the X is O or something else, this activating of this bond. Okay, now the activating agent of this reaction is maybe in general the activating agent which is used is Ac2O, that is acetic anhydride, or maybe trifluoroacetic anhydride. Now I am written over here, activating agent is Ac2O or TFAA, that is trifluoroacetic anhydride. Basically these two are used more prominently. Now the important thing is that what is the nucleophile and what is the co-catalyst. Now here I am taking this as a co-catalyst. Now what is co-catalyst? Co-catalyst is basically which is used it sodium acetate, or maybe some cases SeOH or TSOH, like that. Okay, this also used. Now the important thing is that you get this type of intermediate by using this type of reagent. This is called sulfur substituted carbocation. This is your sulfur substituted carbocation. Sulfur substituted carbocation. Okay, now see, now in this intermediate you have to put this nucleophile. The nucleophile is maybe your OH or O alkyl or O aryl, like that. This may be your OH, maybe your O with bonded with any alkyl group, or maybe some bromide, that is F minus, Pr minus, like that. Okay, this is your nucleophile. Now this nucleophile is selectively attached to this position, that is your alpha position. Okay, now this is your product, and now after the hydrolysis of this product, this bond is selectively cleaved, and you get the final ketone and this rest part of this. Okay, so that is how the overall reaction proceeds. Now see the mechanism, now how the reaction proceeds. Now the mechanism of this PUMMERER rearrangement consists of 4 steps. Now the first step is the acylation of the sulfoxide oxygen, that is this is called your I already said that this is your sulfoxide bond. If the oxygen is placed over this X, now this is your sulfoxide. Now you have to acylate this sulfoxide bond. Now how to acylate this? Now you have to use the reagent, that is Ac2O in presence of SeOH or maybe NaOH. Okay, now Ac2O, I have written the structure over here, that is Ac2O is like that, acetic anhydride. Now this is an anhydride bond. Now if you can break the bond like this, oxygen is a negative and sulfur is a positive, and that is how it make the corresponding resonance structure of this one. Now this oxygen is negative charge, it will attack over this carbonyl bond. The bond is go back to the oxygen. Now you get this type of intermediate. Now this intermediate O minus is back to here, and this bond will go back to here as and leave from the system as a OAC minus. Now you get the final product like this after this Ac2O addition. Now there is a important step of this is that is the alpha hydrogen. This is your alpha position and this is your alpha hydrogen. Now this alpha hydrogen is leave from the system by this way. Okay, this OAC minus is free, it will take a proton. This is just because of this is acidic proton, and that is why it's leave from the system. And here you have get the negative charge over this alpha position. Now, okay, this is your alpha position. Now this now see, this is also a leaving group, this OAC as a OOC. This is your acidyl group and this is your O. And if the bond go here, and this will leave from the system as a OAC minus. Now see, this is your OAC minus. Now this is your alpha position. Now if you use a nucleophile over here, now these bonds go over back to this alpha atom to neutralize this sulfur, and you get the final ultimate product like this. Okay, now you after that, and if you hydrolyze this product, now you get the product like different things. If the nucleophile is OH, if the nucleophile is water, anything can be used as a nucleophile. Okay, now see, and the nucleophile also used as a and I'm written over here the nucleophile which is used is maybe water or maybe some alcohol over here. Okay, now see, this is how the reaction proceeds. Now the important thing is that the questions. Okay, now you have to know the question which was asked in different types of exams. Now question also asked from this different types of topic. Now here I am taking this question, and we will try to solve this question. Okay, now the question the question is came in GATE, IIT GATE 2015. The question is asked that you have given the structure like this, and Ac2O, NaOH and water. Now see, we all know what is the activating agent. The activating agent is Ac2O, and NaOH is our coke catalyst, and the O2 H2O. Now see, this H2 is our nucleophile. Okay, you have to keep in your mind that H2 is our nucleophile. Now see, what is the mechanism and how the reaction product, and how this four option you can eliminate the and resting your final answer. Okay, now see, you get your final. You have given the structure like this. Okay, double bond O, your pH. Now this is your Ac2O. Okay, now what is our product? We know that this bond will selectively break like this. We get this product like this way. See your Me, see your pH. Now this will attack over this center. Okay, like this way, and this will attack selectively over here. These bonds go over here, and this will leave from the system. Okay, now you get finally the product, that is this one. This is your methyl, this is your positive charge, this is your OCOCH3, and this is your pH. Now what is your alpha position? Now see, this is your alpha position. Now you have the hydrogen over here. Now the OAC minus is free from here. Now this OAC minus will take a proton from here, and you get the negative charge over this position. Now when you get this negative charge, what will be our product? Sulfur is positive. This is your pH. This is your OCOCH3. Okay, here is your negative charge. Now what we know that these bonds go here, and this leave as a system from OAC minus. Now this OAC minus is free from the system as a minus OAC minus, and ultimately you get the product like this. This is your OMe, this is your double bond, this is your pH, and here is your positive charge. Now see, the nucleophile which is used in this reaction, that is water. Okay, so we know the water oxygen has a lone pair of electron. Now it will selectively attack over this alpha position, and it will go back to here. This is your alpha position. Now ultimate the product we get, that is this one. This is your SPH, and this is your, I am written over here as a minus H plus. So ultimately we get this product like this. Now this PHS is very much easily leaving group from the system as a PHSH, that is minus PHSH, that is phenyl sulfonic acid. Okay, it will easily leave from the system like this way. Okay, So it will easily leave from the system like this way, and it will leave from the system as a minus PSSH. And PSSH, after leaving of PSSH, we get our desired product, that is our ketone. That is, we also seen over here, that is, we get the nucleophile and hydrolysis, we get this type of ketone, and the resting part leave from the system as a SH bond. Now here is also happening the same thing. Now we get our ultimate product. This is our ultimate product after this rearrangement reaction. So this is very much important. Now you can find your answer, that this is not our product, this is not, and our final product is answer D. Okay, so this is how this product obtained. Now let's move on to the next question, which was also recently come in CSIR-NET December 2018. Okay, so the question is that you have given a substrate like this, you have to predict the major product, and you get the metachloroperbenzoic acid 1 equivalent and Ac2O and aqueous Na2CO3. Okay, now see that you don't have given the sulfoxide bond. Okay, so that's why you have to know few things, that what is the role of this MCBPA. Now the another important role, I already made a video on rearrangement reaction on a question which was asked in IIT-JAM 2019, where I am discussing the property of this metachloroperbenzoic acid. Now here is another important criteria or important role of this metachloroperbenzoic acid, is that it also forms the sulfoxide type bond. Okay, now not only this metachloroperbenzoic acid is formed the sulfoxide bond, there is another reagent, that is NaIO4 is also formed the sulfoxide type of bond. Now I am written over here that if you have this substrate like this, and if you place this metachloroperbenzoic acid, and or maybe NaIO4 is also used some different cases, then you get selectively this type of bond. Okay, so these things you have to know. Now our product has this SPH bond. Now this SPH, now we know what will be our product, that is metachloroperbenzoic acid from this sulfoxide bond. Now how to identify this reaction, and this is, if we know this reaction, if you know this role of this metachloroperbenzoic acid in this case, now you can easily identify this reaction, just because of this is a sulfoxide bond, and you have this activating agent, and you have this Na2CO3. Now okay, now see how the reaction proceed, and how the importance of this reaction. Okay, and how get you find your final product. Now this is not, this is a double bond, this is your SPH. Now you have placed this metachloroperbenzoic acid. Now you know what will be our product. This is our, I am written this bond like this way, that is this breaking of this bond by this way. Okay, now if we know what will be our product, if we use Ac2O on this type of compound, we get the final product like this, this OCOCH3, and here you have the pH, and here you have the positive charge. Now what we know, that OAC minus will leave from the system. I am not doing this overall mechanism. Now OAC minus is free. Now here you have this hydrogen which is acidic, that is alpha position. Now this OAC minus takes a proton from here, and these bonds go here, and this will leave from the system. Now the ultimate product which you get is that this one, double bond O, this is our SPH, this is your positive charge. Now see, the OAC minus is also free from here. Now see, in case of this, in this reaction, no nucleophile is given, so the OAC minus is free, so that will attack as a nucleophile. So this will attack over here, and you get the bond over here. Now the ultimate product that you get is double bond O CO CH3. Okay, now this is our product. Now after this reaction, we have given that aqueous Na2CO3. Now what is the role of this aqueous NO2CO3? It is just hydrolyze this bond, that is in case of this type of ester bonds is readily hydrolyzed by this type of weak bases. Okay, so this is a hydrolysis step. This is our hydrolysis step. So from that we get this type of bond. This bond is hydrolyzed, so we get this OH, and we now see this is our product. Now what we know, that these bonds go here and it will leave from the system as a phenyl PAH-SH, like over this way, and we get our ultimate desired ketone. So we know what is our ultimate product. This is our ultimate product. Okay, now see, find your answer which is given to you. That is, this is not ring migration is not occurring over here. That is, if there is this is given just because of if you do this bioavailable oxidation, you get this type of product, but this type of product is not happening over here. This is also not happening, this is not also happening, and this is our final product, and this is your final answer. And this question is also asked for 4 marks. Okay, so this is for 4 marks. Now see, this is very much important for your exam. I hope I will cover I am covered all those topics related to this PUMMERER rearrangement, and also discussing the different kind of explanation, different mechanism, and also this previous year examples also solved regarding this PUMMERER rearrangement. Okay, I hope this video is very much useful for you guys, and if you find this video useful, you can share it with your friends, and thank you so much for watching for this video.